All right, today we're going to dive into a pretty fascinating journey. And it all starts with, well, a simple earthy problem. What do you do with a giant pile of cow manure? But this story, it goes way deeper. And it ends up questioning the very foundations of how we think about technology, nature, and even progress itself.
And it all kicks off with this one powerful question from a student named Steen. But what if the premise is a completely different one? You know, this single thought, it was the thing that would unravel everything he and his friend thought they knew. And honestly, it's the central idea we're exploring today.
So let me set the scene for you. You've got two students, Kesser and Steen. They're researching how to recycle waste from cattle farming, and they stumble upon this dusty old research paper from 1981. At first, it seemed like it held the perfect high-tech solution, but what they discovered instead was a profound conflict, a battle between two completely different worlds, a high-tech factory versus an ancient forest.
All right, so let's get into it. Part 1, a 45-year-old idea. Their story really begins with this rediscovery, an idea that had just been sitting on a shelf for almost 50 years.
So this paper they found, it's from the U.S. Meat Animal Research Center, and it basically outlined this brilliant method for turning manure, something everyone sees as a waste product, into two super valuable resources, energy in the form of methane and high-quality protein for animal feed. I mean, to these students, this looked like an absolute silver bullet.
So the core technology here is called anaerobic fermentation. And look, in simple terms, it's a process where you let microorganisms just go to work breaking down organic stuff like manure in an environment with no oxygen. And the main thing that comes out of that? Biogas, which is mostly methane.
But the real secret sauce in this old paper, the thing that made it so special, was the use of a specific kind of microbe, thermophilic bacteria. Now, these are basically heat-loving bacteria. They thrive at a pretty toasty 45 to 55 degrees Celsius, which makes them incredibly fast and super efficient at just tearing through that manure.
Okay, so with this incredible idea, what did the researchers back in '81 actually build? Well, they essentially created a mechanical version of one of nature's own wonders.
And this is really the best way to think about it. They built an artificial cow stomach. A cow stomach, right, is a natural bioreactor. It digests grass and produces methane. This technology just takes that exact same principle, but puts it inside a highly optimized, totally sealed tank, so you can capture every last bit of that energy.
So here's the step-by-step. First, manure gets fed into this sealed tank. It was about 5.7 cubic meters. Then, those heat-loving thermophilic bacteria get to work, digesting everything at that hot 55 degrees Celsius. Out of that comes biogas, mostly methane, which gets captured. And the stuff that's left over? It's a nutrient-rich byproduct that's actually a fantastic, high-quality fertilizer. It's a total win-win.
And the results? They were absolutely staggering. The system produced 4.7 liters of methane every single day for each liter of volume in the fermenter. Now, to put that in perspective, at the time, this was the highest rate ever described in any scientific literature. We're talking 4 times more efficient than other systems out there.
So what does that all add up to? Well, from this relatively small tank, only about 2 meters in diameter, the process could pump out almost 27,000 liters of methane every single day. The energy potential here was just immense.
So let's translate that into something we can all understand. That daily energy output is enough to provide all the electricity for 7 or 8 homes, or enough heat for 5 to 6 homes. And here's the really mind-blowing part. All of this is generated from the manure of just 4 to 6 cows. It really seemed like the perfect solution, right?
But just as Kesser and Steen were getting really excited about this incredible piece of technology, a little doubt started to creep in, a question that was about to change their entire perspective.
And here it is again, that question from Steen. But what if the premise is completely different? What if the very foundation of their thinking was just flawed? What if they were putting all this energy into solving a problem that maybe shouldn't even exist in the first place?
This is the moment everything clicked. They realized that a huge pile of manure is only a waste problem in an industrial farming setup, where you concentrate hundreds of cows in one small building. In that context, yeah, it becomes a pollutant that you need a complex, expensive factory to deal with. But what if the cows are just grazing in a forest? Then their manure isn't waste at all. It's a natural fertilizer. It's a gift to the ecosystem.
So this realization, it sent them down a completely new path. They started comparing their high-tech factory idea to an ancient low-tech alternative.
letting the forest do the work.
And when you put these two systems side by side, the contrast is just stark. The bioprotein factory needs raw materials, often fossil fuels like methane. The agroforestry system, it runs on sunlight and biomass. It's free. The factory requires a massive capital investment. The forest, minimal investment. It really boils down to this: a technological fix versus an ecological solution.
And the economic difference is, well, it's not trivial. We're talking about an estimated 200 million Danish kroner in saved capital by not building that industrial bioprotein factory. That is a staggering amount of money, all saved just by letting nature do its thing.
Okay, but this next part is maybe the most astonishing discovery of them all. The students realized that the wood waste from the forest, the branches and chips, could be used to grow gourmet mushrooms like Shiitake. And get this, per hectare, that system could produce 250 kilograms of pure protein. A single calf raised on that same land, it provides only about 50 kilograms of pure protein. So the forest wasn't just solving the waste problem, it was 5 times more productive at creating food.
This whole discovery, it revealed something much deeper. This wasn't just a choice between two farming methods anymore. It was a clash between two mindsets, two futures, two fundamentally different ways of seeing the entire world.
Let's break down this core conflict. On one side, you have the industrial mindset. It basically sees nature as a machine, something to be optimized and controlled. If a problem pops up, you just throw another technological fix at it. But then you have the ecological mindset, which sees nature as a complex, intelligent system that you need to work with. The solution isn't a new machine, it's usually already there, hidden in the biological cycles.
And this divide, it goes all the way down to the economic drivers. The industrial model is all about quick profit. It focuses on short-term, centralized financial returns. It values liquid assets, like stocks and cash, that you can move around quickly. The ecological model, it's about long-term resilience. It focuses on slow, decentralized value, and it treasures illiquid assets, things you can't just sell tomorrow, like healthy soil, clean water, and biodiversity. These are things that pay dividends over generations, not just the next quarter. So you have to ask, why is that industrial mindset so powerful? Well, this quote offers a really compelling explanation. The desire for a quick profit is like a serotonin fix. That rush you get, it triggers the same reward centers in our brain that evolved to help us survive, to find that high-calorie meal. It's this deep evolutionary instinct that was once crucial, but today it might be risking our entire future.
And so their whole journey really leaves us with a fundamental question. A question about what we're even trying to do with all our innovation. Are we just building ever more complex machines to fix the problems that our last machines created? Or are we learning to work with the genius of the systems that are already here, systems that have been running for millions of years? That's really the question at the heart of this whole story.